Okay, so let me introduce our speaker. This is Tyler Tallman, sitting right next to me. He is the CEO of BreezeEHR. They do a lot of cool stuff with Clojure, always interesting, always cutting edge stuff. And so this is something that I'm really looking forward to hearing about, is some of that cutting edge stuff. And so I won't say any more. Take it away, Tyler.
Thank you,
Eric. All right, the title of this talk is The Life of State. I thought this picture was fitting. The lion on the same boat as you. You know, as functional programmers, we're always trying to, have as little state as possible, have pure functions that don't have any side effects. But there is some essential state. So I'm gonna start. When we go off, we're just gonna have a kind of open discussion, kind of let you guys interact a little bit with your thoughts of state. So, what is state? Anybody have anything else other to add to that? State, not Vermont, the other kind of state. What is state in a React app? Like, give me an example. Any of you guys write in React? No? Oh, we got a couple.
The text that's in a text input.
Text and text input. That's a good example of state. And we also have a lot of frameworks that manage like that state and the loading of state on the outside, like Redux and any other examples of what you guys use to, bring state from the back end or the server. Any other?
Ajax.
Just a straight up Ajax call.
Global variable.
Global variables. Perfect. A perfect example of what happens very often. What about we maybe don't think about this, is like we run a MapReduce job, and there's state there too. As you're computing your MapReduce functions or whatever, there's intermediate values that get saved off to a disk somewhere else. I'm going over the real basic things here. There's three. I kind of like to talk about these aspects of state. There's some amount of essential state, which no matter what you do, you're not going to get away from. It's like part of the problem space. But then there's also a lot of accidental state, stuff that maybe we didn't need to save it. It's some derived value that we don't need anymore. And you see the derived state is something you may need for your UI. You may need the count of the nodes, the number of the count of people in your Facebook page or in this list, number of items in a list. That's something that we don't keep around. We don't generally store that in a database. We just keep recalculating that. And that's an example of a derived value. So one of the ways, I'm going to talk a lot about how we load state and keep it around. And so I'm going to briefly go over what George here covered a couple weeks ago. We're going to go basically from promises up to the newer stuff in JavaScript, like generators and stuff like that. So this function here, read JSON, is an example of, I guess, normal JavaScript right now. You have a function, you put the file name you want to read, it's encoding, and then you pass a function into that, which basically the environment is going to put the response value into. And you check back for an error, and you do something else, and then you call another callback. Right there. Now, the first step of this is there's something called a promise, where basically instead of doing all this in the body, you return a object which has a then method. So when you call this read file, it will do its work, and if successful, it will call this then, is whatever you put in the then callback. And so in this case, it's going to parse that file whenever after the file is read. So the first step. Then as we go on from there, we get into generators, and you see here's the promises getting chained. It's sort of it's another form of callback hell. You have promises inside of promises. I know there's methods to chain them, but it's still a synchronous thing. And as we get into the async sort of things here, we can just yield on reading those two JSON, so it reads very much like your regular code. There's just one more keyword here to synchronize. Now this gives us even more advantages, as later on we can now take that same code. We can, if we yield later, now both of these are ran concurrently, and so
that example's not.
this example here.
No, because you're still doing yield one, then yield the other.
That's the top one, but here they're both sent off.
The read JSONs are started.
The read JSONs are started, and we only wait later on.
I see.
So in this example, we've just by changing the way that we frame the problem, we've allowed ourselves to gain nice things like concurrency and stuff out of it. Now, in Clojure, there's something called core async, which allows many of these similar generator and promise patterns, but we're going to take a step and go into typed land for a little while, and I'm going to show you a library that's from Facebook called Haxel. Now, the reason Facebook started Haxel is they have a lot of different groups working on their same data. And as they found a need that they needed a type-safe way to be able to pull a whole bunch of information together to work on it. And so this is their attempt. And we're just going to walk through briefly and show what it looked like to make one of these Haxel things. Feel free to ask any questions. This is I've allotted for time to just handle basic Haskell syntax and.
Sorry, that answer the question it's Haskell, right?
Yes. So this is Haskell code, and I'm not going to dig too deep. If you want to go off into extremely deep type theory land, there's a meetup Mondays for that called Haskell Cats, but I'm just going to cover the basic syntax and what this means and try to walk you through what's happening here. So this data part up here is where you make a data declaration. This, I believe, is Evan in the room? No? Back there. Okay, well, anyway. It's basically saying we're going to make a Facebook request, and there's going to be 3 different kinds of requests that we make. A get object, which takes an ID and returns a Facebook request with the value being an object. Get user, which takes a user ID and returns a Facebook request with the user. And get user's friends, which takes a user ID and returns a Facebook request with a list of friends in it. So right below it, this is what interacts with, and I left off a lot of the includes and imports, but you can basically think of it as this fetch request is a type class, and you're going to implement you're going to basically, I guess, what's the proper word, Evan? Implement, instantiate? Instantiate an instance of these for each of the objects, or each of the things we created here. So, for instance, we're going to say, how do you implement the fetch request on get object? And so, in this case, we are just proxying basically to the service behind it, that service that existed. And so, basically, just each of these things are proxy service. In the case here for get user friends, it's going to fetch all the next pages. So it's stringing those together. We don't want to get too bogged down into this, but just realize you're implementing something for each of these objects. You created a specific data representation of each of your requests. That'll become important later on. And then basically you wrap a function on the outside to use these. And notice the gen Haxel here in the return type. That will come back as well. Then basically to run it, this is their main function. which is basically provides a context to do these things. They do all the dirty work of getting the credentials and instantiating some global state here. And then this is where the magic is. Inside this run Haxel section here, you can call those, you can put in those things that we specified earlier, those functions that we just made in the last page, and you can call get object, get a person's likes, and then using this map m, normally you would call get the likes, and you're getting all the like IDs, and get object, as we defined it before, would have called in the naive implementation would have called an XHR for each of them, or hit the server for each of them. But using mapm, it's able to get that whole list of IDs and batch that whole request. So basically, you write things very similar to you would just looping over things or mapping over things and getting their values. But behind the scenes, it's going to batch them together and make larger requests. Feel free to ask any questions. We'll open it up.
Does it have any magic to figure out, like, well, this is a big enough batch, we're just going to send it now?
There is no magic that I saw. Of course, there's a lot to the library. I may have missed some of it.
I'm just going to re-ask the question that you
Yeah.
said. So you said, like, if you were going through IDs 1 through 5,
Yeah.
instead of it hitting the database, ID 1, ID 2,
Yes.
ID 3, ID 4, so it knows, the magic is it batches them.
The magic is, even though this code is sequential, even though it's mapping over this get object function, it's able to make one large request behind the scenes. And we're going to go a little bit into, like,
And mapm is something that's from Haxel.
yeah, this is Haxel specifically. The traditional map, you will only see one at a time,
Right.
and this is another kind that allows it to, an applicative functor, I believe. But
So no matter how many requests to the same thing there are, it'll batch them all together. Like that's what Eric was asking.
yes,
So it's not going to like split them.
it's not going to split them.
But it is hitting their API, so their API
Yeah,
can.
I think they could make that choice, and you'll probably get a better idea later on. We're going to go through one more of their implementations that makes SQL requests out the back end, so if we're familiar with SQL, we'll be able to see that a little easier.
Is this stuff that's exposed for the public to use?
Haxel?
Yeah.
Yeah.
But first of all, is Haxel specifically for querying the Facebook API?
No, later on we're going to show you a version that uses SQL as a backend.
Okay.
They were just that example there. Those other calls, if you would have seen all the imports, there's a Haskell Facebook library for the Graph API,
Okay.
and so those were just basically proxying those methods through. So here's some examples of similar things you can do here. Those are the simple examples, just each returning the Haxel object. So now you can do something like friend of friends really easily. Again, batching. So in this case, you get the friends of this ID, and then you do the map here, and that's going to end up doing 2 requests. Did one request for the friends of this person you passed in, and then it batched all of the friends of those friends.
So it solves the n+1 problem.
Exactly. It is the n+1 problem that they're after solving here. So, and here's another example that's even more fun. It pulls the friends of 2 different people and does a quick intersection of them. So this is very helpful when building a service to be able to, express these things in as few lines of code and have them batch. There's a simple implementation everywhere, but you'd end up with, like, if it were directly hitting the back end, we just don't allow that to happen. So a lot of times people will end up writing a new, some new service endpoint for each case, or whatever the case. And in the case of Haxel, most of these are some back end microservice, kind of proxy. They expose this here, or they're making these calls for something like determining whether there's been a security event or a bunch of things like that. The security team and some others and the spam team use this a lot.
So do they have a standard for what the server needs to be like?
Well, Haxel says nothing about the server in specific. But see, the previous thing was the implement, like you implement it for each thing. And so we're going to go on here.
So is Haxel basically just building the request up?
Yes.
Okay.
Haxel is building up that request, and it's using, that map
And
magic.
something else sends it out.
Yes. So here we're going to make a real simple one. This user request can do a couple things: get all the IDs and get the name by an ID. And this, you can see here, it's building strings for SQL. the grossness that we have all done, and basically it's making these blocked fetches here, as you can see, and those are where the synchronizations happen. So basically, unless this is null, it will select all of the IDs and then put that into the all IDs. And the basically this is the one that supports the getting names from each of the IDs.
So it's just oring up.
It's just
all of
oring up all those IDs and getting their names here, and doing a little bit of fun unzipping them there and getting them back in the form they need to be.
But this isn't like a good way to do that query, so like you would...
Yeah, I mean...
All right, yeah.
Yeah, this
But
is
you would
this is
be
straight
able
from
to-
their example. You can
Okay.
do all kinds of,
Right.
basically do all kinds of things. But I'm just...
Well, what's a blocked fetch? I'm sorry.
So the blocked fetch is a data type, which is basically where they're doing their synchronization on. So it's what ends up being where they wait to go to their next unit of computation. But anyway, the point here is there's a lot of ways, just like with the promises and with the generators, that we can possibly batch up work if we're able to wait long enough. So and here's an example of using the same thing. They're doing a for here, really, synchronous filling code, but it parallelizes that second round as well. So the library we created is called Hitch. It does some of the same things without some of the benefits of the strongly typed nature of Haskell, but it basically, we define data types for what we call selectors, an overloaded term. I know some of the React frameworks use it and stuff like that, where we basically name the different parts that we want to pull out and send from the server to the client or whatever the case. One of our long-term goals is to be able to choose, not in the beginning, but later on, whether we want this code to run on the server or in our JavaScript client. So that's a longer story, and we're not going to go too deep into that here, but that's one of our design principles. We want to be able to batch requests. So basically, we primarily use this on our front end now. Basically, every time we're in a React render, we have the equivalent of like a set timeout 0, and everything that the user interface requested during that render will be a request that will be made for it on the next time. So, was there a question? No? Okay.
So I was thinking, so if you would manually, going back to the thing you said you worked on and talked about, sorry.
Okay.
So if you had the option to decide whether or not you would do the computation on the client or the server side,
Mm-hmm.
would that be something you would want to decide up front? You'd want to delay that for maybe the data size or?
Yes. Like to design one way. So imagine the story, you're doing a computation, and it's really just, it ends up being you don't expect it, but it ends up being the most expensive one, and your mobile phones are operating really slow when you do it there. Something that you would choose to run on the server. Or the opposite case, this is something that gets hammered on and changed all the time, and it's just some simple derived data, and you'd want to be able to do an optimistic transaction and have it show up right away on the client. You may move it to the client. But being able to choose that later is very helpful. And there's a couple other axes we can make decisions on there.
Just a quick question. So you had that thing that was doing the intersection of like friends of friends or something like that?
Yeah,
There's like friends in common.
right.
So that intersect is happening on after the two requests. It's
After
not-
the two requests, yeah.
It's just regular
It's
set
regular
intersect.
set intersection, yeah.
But you could have a thing that does intersect and makes a new query.
Makes a new query.
It turns it into SQL or something.
Yeah.
That's why I think collapse the whole thing
Yeah.
and have it done on the server.
Right, right. And the more you can collapse, the better.
And so that's the kind of thing you're talking about, moving it from the client to the server.
Sometimes, yeah.
Like you could implement
You can
intersect
implement
that
more
works.
efficient things. Like this is a perfect case. Like if you just turn this directly into a SQL query, you win big here.
Mhm.
This is a lot like link providers in .NET, actually.
Right.
I was gonna say.
Similar
Yeah.
logic. They're using like list comprehensions is where the link providers came from. Haskell's list comprehensions, etc.
I was gonna say GraphQL too. It's like you just.
Yeah. And that's the other side of the issue. GraphQL and others. You're trying to say I'm the client. I want this data precisely, and then you figure out how to get it on the server. You push it out somewhere, or maybe there's something to do some of the computation on your in your client, and the question is maybe with microservices there's that layer of can this get to who can most quickly give me the answer I want. So going back here, did I finish everything here? So batch requests, and so the other thing we add is we use core async for a workflow similar to generators in JavaScript that we just saw there. And so I'm just going to go through a few quick examples and do it again. So basically, this is my example. I made a quick Facebook service here. This is a record in Clojure. This is another place where there's a ton of syntax, but this is how you define a record. So it's a record Facebook service with one field, credentials. And these are different protocols or interfaces, depending on where you come from. And basically, you can think of what we're doing in Hitch as we have some selectors that are pure, but for the other ones, we set up state machines. So if you have something like Redux, or you can think of it like an Erlang actor too. We let the user define a state machine to keep their state up to date, and that's the effectable selector here. Is a reducing function which basically it gets events and changes its little window of state, and it can return. This gets called when all the changes have finished for that round. We give our the graph has from the outside has a transactional boundary. So once you read or transact in some other way, it will make everything consistent before it gives the control flow back to the process that was calling it, like a generator or whatever the case is. So in this case here, for this service there's three things that can happen to it. A dependency can be added, and in this case that dependency, let's go to the other page real quick to see an example of some of these. So these are just those same Facebook requests. And basically all they do is they get the Facebook service, and when they do that hitch, they're added as the dependency they have is on that service. And so the service gets an add dependency event, and the service can now see this request and make sure it's in its database. It won't be to begin with. And then after that render is done, the callback will be called, and it will have an opportunity to batch all of these selectors that depended on that service. And basically all they do in the end is they pull their value out of request right there. They pull the user value out of the requests. I'm covering over this. If you have any questions of Clojure syntax, you can. Otherwise, I'm going to leave it. I'm just going to keep moving as we go here. But
So the previous thing you showed was
Yes.
Clojure script, right?
Well, these are both, I
Okay,
mean,
and that second,
yeah.
okay, so this Clojure script, is that Clojure?
They're both Clojure
Or
scripts.
this is Clojure script?
This is a subset that is the same, identical on Clojure and Clojure script,
Okay.
unless I put a JS in there. I think this one actually has a JS, yeah. So that is actually, that's calling their, it's calling their object. And what happens in Clojure is a little more straightforward since you have the full set of concurrency tools Java has. But here it's basically set timeout in JavaScript. But yeah, so this basically here, just going back, we have a couple choices. One is to make that selector, to make that object that the request will be resolved for. The other one, if you can't do it on a service like this, but if it is a pure selector, you can just call it directly as a function, and it will eventually go down to collect its values. I have an assert there because it is a service, and you can't do that. And so here's just those simple selectors for these, and here we're just going to implement. This is the same thing you saw earlier, friend of friends. And so we use this is basically yield. This async arrow is yield in Clojure script. So we're able to do these similar things. And this is a function which asks for more user friend services.
Is the go block implicit?
Yeah, the go block is implicit in def selector, yes. So anyway, I was just going to go over and introduce that briefly. But the most interesting part is this frees the user to define. You see, these depend on the ones we displayed on the next page, and you can have them built up in this giant tree of dependencies. And for our version in in Clojure script, they depend on them until we have basically a React manager. When the React components are mounted, it will it'll undepend them, and eventually it will clean up that garbage for the next thing. So you can be moving from page to page, different demand, and then eventually it's cleaned up as you keep navigating to other pages. And one of the benefits is these are really fine-grained dependencies compared to having one large XHR that you had there. And it allows, really we found that it allows us to focus more on, so we have Datomic has a notation. Let's see if I can just pull this up real quick. I don't know if there's a good example of a pull request. I don't know how to get out of full screen. There we go. Another window. So to your question earlier, of how do you get as much as you can in one request? Well, what we're trying to get to send to our server are these pull requests, and I'm trying to see if they have a good example here.
Has nothing to do with.
Yeah.
Okay.
That's the first thought.
Or sorry, yeah, nothing to do with get pull requests.
Okay.
But for instance, this is a pattern, and basically when you see the maps there and these keywords, it means get that attribute. So
Tyler, can you make that
Yeah.
bigger full screen?
yeah.
The font size, probably.
Nice. Oh, much better.
Scroll over, we'll be in even better shape. There you go. Okay, so it's saying that this entity you came on, we just want one attribute from it. It's very similar to the GraphQL stuff. So you want the release media, and of those release media elements, you want to have just the attribute media tracks. And of the media tracks, you want to have just the track name. And of the track name, you want to have the artist and the artist name. And so then you get data out that looks like this instead of the whole database. It's a subset you need, especially for doing a render. So you can compose a lot, just like GraphQL queries, and you can build these up pretty dynamically just because they're data as well. But so these are the kind of things that we do. We want to have like basically one of these at the top of our page where we can say, we want this right now. It Hitch, it's requested. You have the object you need, and occasionally there's boundaries because however we make our selectors is where we have to handle and manage whether this data is loaded or not. So, you know that phase of that, when you start up a React application, there's that initial phase where the data is not loaded, and you have to handle it there. And if you split it into multiple chunks, every chunk you split it up in, you have to handle that. If it's loaded, show a spinning wheel or whatever the case is. So let's show menu. Do this again. But anyway, so this basically allows us to set up our derived data however we'd have it, and it gives us, it helps us to name things. We name those things in composition. You saw the friend of friend is just another, it's basically another record, but it just references an ID of that sort. It allows us to memoize things, so a lot of times on the client side you have a heavy computation, and if it's behind a selector, it's automatically memoized. The same selector is pulled out each time and shared by every instance. And the late binding of location is something that we've been working hard, and you'll probably see more of that as the year goes through, showing fun toys.
Can I ask one thing? So, you said the selector, is it going, it is hitting the database?
So in our case, like there's a couple options. So that's something that's late bound for us. So we have something that interprets that selector on our client side and basically communicates to our server over datums. Just makes additional datums requests, which is like an any attribute value, like you can think of it like RDF data. Just sending those, this entity has this value at this attribute at this time. And so we have something on our client that fulfills basically all those selectors by datums. The other thing is we can send it directly to the server, and so if I ask for this entity attribute, it'll just return a map instead of the datums. So again, so there's a whole bunch of choices that can be made later on, which is interesting and exciting to us. And yeah, I thought this brings really interesting questions for microservices, like, if, basically deciding where this happens. You could have it all go on a monolith, right? Something that could satisfy all these selectors. One monolith could satisfy a lot, but maybe there's reasons to separate them for the purpose of pooling their resources, like if they depend on the same common set of data and you keep it hot loaded in memory. Is an advantage of splitting, another advantage of splitting into microservice. There's just a lot of trade-offs that when you can give up on caring where this has happened, or you care, but where you can choose that later, it lets you choose where this execution is going to happen. So, and yeah, that's basically it. I just wanted to go through that, show you what you're doing, hear feedback from anybody who has any thoughts on how we could do it better or different. And if you have any questions on Haxel, I'm sure Evan can answer them.
I just heard that. That sounds awesome.
Yeah, we'll probably be doing. I'm really curious for feedback on Hitch and just hearing what you guys are doing to manage your state in JavaScript and on your service. So,
would you mind putting the code for the big Clojure code?
Yeah, the service.
Yeah, I didn't really get a chance. No, the Clojure.
Yeah.
Yeah, that one.
Okay.
Yeah.
Yeah.
I just want to read it while people are asking questions.
Yeah.
So there might be some cases where you have like a cache of data locally that's still fresh that you want to hit instead of like going straight to like other sources. Is that something that could be supported?
Yeah. So in our model, what we generally do is these selectors, we subscribe to the selectors, and so the service I talked about, that's the datomic service in JavaScript, subscribes to that selector on the server and gets updates every time a datum that affects it changes. So, and it does it transactionally. So every transaction on the server will give one transactional update to the client. Transactional for that database scope. I mean, there's still distributed systems outside that if you have multiple databases or something.
Server don't care, you just read it from the client, or you just read it from the one place.
That's the place for a lot of what we do. But there's still the optimistic commits you want to do. Like, you want to try a transaction and you want to show the user that before the request makes a round trip. And we don't have that solved yet, but we've been working on it.
Is any of this more specific to Datomic because you're leveraging that? Is it more integrated because of that?
Not really. So none of this is Datomic specific. We used Hitch in making our Datomic specific client, but the goal is you can do it with or without Datomic. Any REST interface or anything will work just fine.
When you said you wanted to make optimistic changes on the client side, what's a concrete example of that?
So a concrete example is let's say you're updating a counter, and you want the number to show back before it's been confirmed on the server, before it's transacted to the server. Imagine count is really expensive on the server, or network connectivity is really bad, and it's disconnecting, it's buffering up those writes. You're still showing the user their changes, but there's still, since it hasn't gone to your source of truth, there's a possibility that those transactions will be reverted back to where they started if they failed.
Maybe too simple, but like you're looking at your Facebook friends, you delete someone, and you just first your optimistic guess is let's just -1 on the server side, and then then we'll hit the database and make sure that it's actually an accurate.
-1 in the client.
That's what I'm saying. Right. -1 just some variable in the client, but then like.
And the server comes back and says you actually lost 10 friends in the last second.
Right.
And then you remove that change that you made on there and add the new change. Yeah, that's really what we want to. We want to get there. We tried earlier, but we aborted because it was causing too much pain. So that's where we're at right now.
It's hard to keep people updated.
Cache and validation and naming, they're the hardest
They
things.
talk about the Facebook specifically as super, just like why they designed super complicated, like because they had these things called like cascading changes. I think that was like the and I was like, yeah, that definitely state is probably. I think it's there's probably no application in existence that's as big as Facebook. So it's like, the use case is, but of course they're going to be ahead on tooling, especially when it comes to managing state.
But they still run most of it on PHP, so.
Well, whatever their version, hacker, whatever their version.
Yeah.
Some of this reminds me of the RX,
Yeah.
well, RxJS, or RxJS, whatever.
Extensions, yeah.
Yeah.
Very similar kind of story. But yeah, I know. I hope to. Anyway, I'm going to try to give this talk later somewhere else, where I'll have a little more formulated some of these things. This is our current version that I'm just showing here that we have. We have working on mainly that Datomic syncing instance there, and we're going to start using it more widely and see how it goes. But so far,
Seems like
super
Datomic
excited about
might
it.
be a particularly easy implementation of
It is,
too.
exactly.
Yeah, like SQL would be
Yeah.
you're building it or having the.
Yeah, you're right. It's
A lot of nested SQL statements in that.
a lot of recursive SQL statements. Yeah.
There's some corollaries to SQL here too, because it's like when you write SQL, you're just writing SQL, right? Do you really care what the underlying database is? I mean, you kind of care, but SQL is SQL everywhere.
Well, but the other point is,
Have you looked at what entity framework generates? No.
you look at all the examples
the
there.
performance of the queries, right? Like you tell the database, give me this information, and however you want to get that relative to like whatever pages are accessed or disk is the
Right.
database's problem.
Yeah.
Right, exactly.
But SQL, the problem is SQL statements don't compose that well, so you're gonna have to write one SQL statement per query.
Yes.
Whereas with these, they compose.
Yeah, but I guess what I'm just saying is
What do you
that
mean?
you're just declaring what you want.
You could wrap it in a
Yeah.
function.
What do you mean you would have to run one?
Well, so if you're
You have to
depending
write
data comes back and you have to be like, oh, now take this and then do something else with it.
If you have to do it,
You kinda
so
just-
what he's saying, what I assume he's saying, or understand he's saying, is that you could just write the SQL. And if you have to write the SQL for every possible query, it's a lot. But if you could find a way of composing it so that you could have, you know, instead of 1,000 queries, you might have 10 queries and then ways of combining them, and it's much less code.
Another interesting
Yeah.
thing is the things you do here are pretty close to SQL most of the time. And that's, I think you'll find that anywhere you get close to relational algebra, unless you're,
Right, if you're doing set stuff, then you're probably going to do SQL does.
yeah. But you'll never be as fast as Postgres. That's the other, the other side of it.
This reminds me, we should talk, because a SQL backend for this, I actually have a library that I've started a few times that is it's a relational algebra that generates SQL. So you do relational operations, which
Yeah, I
are
tried to do that once
composable.
before too.
I know a guy that's a Postgres core committer in Philly. That's a Clojure guy that tried to do the same thing.
It's the white whale.
That was like trying
Do
to.
it.
I think it's possible.
Another interesting thing here is doing authorization against selectors, like which selectors does the person have permission to read versus, and so your whole layer you expose these, and I'm extremely crazy. I have a version of this that I want to get running on IPFS. I don't know if you've heard of that.
Yes.
Yeah.
What is that?
It's basically like Git for everything.
Interplanetary
Yes.
file system?
Yeah, exactly.
yeah.
Interplanetary
Say
file
the
system.
4-letter word.
Sorry. But basically, it's a hash of everything's hash. It's hash.
Yes.
And it's
It's like making everything.
it excites me greatly, and I will implement a version of this where the selectors can be downloaded and eval from the hash. Basically, there's one root hash, and you could pull in the selectors implementations.
IPFS coin? Is that like?
There's no IPFS coin that I know of.
No, there's.
Yeah.
There really is a point.
I believe you. Aaron.
There's a coin for that.
Yeah.
So where do you? Yeah, I have a question. I missed the early part of the talk, but where do you define the interface on the service? element
Service
there?
interfaces. So this is well.
I mean like the
The
transactional
set
interface.
timeout is yeah. You define it above it. I mean, there should be a set timeout
There is
somewhere
a
around
set
here.
timeout.
It's
Pad
add depth.
At dev, yes.
Exactly in the middle.
Oh, yeah. So the function's not there, but it had a function there which basically did the effect working in JavaScript. But it could be doing synchronous stuff if you were on a real server, like
Right.
And so our server implementation is still in the works, but basically, it like for our Datomic thing, it's just calling direct Datomic requests, like loading these datums or whatever.
I'm just curious if like Hitch exposes some level of like choose your own synchronicity or
Yes.
eager evaluation.
Yeah, that's the exact idea. So the main thing, like with Datomic, it was important to send all the changes from a transaction. I mean, Datomic exposes that. So every transaction, we send all the changes that are appropriate. So there is a consistent view. So like especially on the push API, but here too, your synchronous, like you can either synchronize on a T or on a time or some sort of if you can get an older view of your database or
Microservice
something.
endpoint.
Yeah, or
like,
some microservice.
However you want to
But
touch it.
yeah, you don't want to be hitting different things from the same central point because you're going to get skew of some sort. That's why the monolith, in some cases, a monolith that just handled all the selectors could be advantageous because it can synchronize again.
You know how much a function costs, so
Yeah.
run it.
Yeah.
Can you talk a little bit more about the 3 events?
Yes. So the add dep and remove dep are the only ones that are built in special. Basically, the informed selector, that's a marker protocol. And whenever that's on there, they get events when people, when other selectors depend on it.
Okay.
And so those are these two events, and the callback calls resolve request.
Oh, okay. The callback that we don't see.
The callback you don't see here calls resolve request, and it basically it would be a list of them. So to the graph, it would say do these effects, and it would be a list of requests, resolve requests, and resolve them all at once.
So in this one, if I could step through the code, see if I understand it. You send off some request with the add dep, when some other selector depends on you. You send off a request, presumably to Facebook.
Yeah.
Yeah. And then you add a pending status.
Yes.
And
Under
then
that, this is the selector for it.
okay.
So
The name
under
of
the selector, the status is pending.
And then when that Facebook request comes back, you get a resolve request event.
Yes.
And then you save the value.
It sets this to resolved. So you see these are looking for resolved on the status to know whether they can. And these are just, it's basically, they're given the state of the state of that service. And they, like these simple requests pull themselves out, but there's lots of things that can happen on more complicated services. Like the Atomic's a lot more sophisticated than this, but this is just a simple example. And the other nice thing is this one just invalidates the ones that changed. So like if the naive implementation would have, like, if you don't go, I forget what the protocol, there's another marker protocol, but if you don't have that on there, it will just invalidate every, so every selector that depended on it, every time something changed. But this one's intelligent enough to just invalidate these invalidations. That's why it's keeping track of invalidations.
Just the last one that was added, it looks like.
No, it should,
For that request. No, associate
Possibly.
invalidations, and it's just the singleton set there.
yeah, so that's a bug. But anyway, I wrote this real quick.
So it could have some state
in Atomic, yeah, it'd be like a set, and
set in this.
then it takes that set and validates it and removes it from that that accumulator or state machine or whatever it is. And but yeah, that's the story. It's just basically allows you to have a lot of state machines instead of, like with the Redux you'll have one, or with Omnex you'll have one. It lets you have a lot of them, and later on a selector can depend on both. And as long as they have a similar source or something, you can regain your consistency. If their source was the same, which is another thing to guarantee. But anyway, that's the story. I just wanted to show some people and get some feedback. Thank you guys.